Okay, welcome.
I'm Adam Plum. I'm the CEO of an AutoML company called Augur.ai. But I'm not going to be talking to you today about how cool Augur is. What I want to talk to you about today is just AutoML in general, and more specifically, that there's a second generation of AutoML that's very targeted to developers. And that creates a lot of opportunities for doing things in a different way if you're developers. What I'm going to do is talk a little bit about the opportunities that a second generation of AutoML that provides rich APIs makes available. And then I'll actually show an example of where we've used it on a project. All of the techniques and everything that we do applies to any AutoML with robust APIs, and then we'll talk about what those are. And then we'll actually go into a framework that we've made available that's open source. It's completely free, we're not selling you anything, called A2ML, and that actually wraps all second generation AutoML. So before I jump into sort of what second generation AutoML, I found that for some it's worth talking about just what is automated machine learning in general. So I've been at another edition of this conference, so I know you're all machine learning, or most of you are machine learning practitioners. How many of you have used automated machine learning in some form? Google, Microsoft, DataRobot, H2O. Okay, so not the majority, so good. I'm glad I included this slide. So why use automated machine learning? Well, AutoML tries multiple algorithms and hyperparameters, random forest, light GBM, gradient boosting, linear regression if it's regression, logistic regression, just tries all the various algorithms and the various hyperparameters. And of course, that's by definition an infinite problem. There's an infinite amount of hyperparameter knobs that you can set. And so there's the challenge of it. As a result, if you haven't sort of touched AutoML in a while, maybe you played with it a while ago or you saw results, maybe 5 years ago, AutoML maybe didn't do as well as something you could hand tune. I'm going to make a very controversial statement, and this is not bragging about Augur. AutoML in general has progressed to the point where it can outperform what you're doing by hand selecting algorithms and hand tuning hyperparameters. Now, the typical data scientist, I will tell you, is very annoyed by that. I would say 80% of them don't like that. There's lots and lots of room for data scientists to guide these things, do things like trade-off between accuracy and explainability, and sort of validate interesting techniques to validate the results. But what I found is that most data scientists are spending a lot of their effort, most of their effort, of course, gathering up the data and selecting features and targets, and that doesn't go away with AutoML. You still have to do that. They're also spending a lot of time choosing and hand-tuning algorithms, and I would encourage you to consider at least trying AutoML to do that. Years ago, when DataRobot first started, it's quite an expensive product, and it was a little cost prohibitive to do it. So a lot of people just said, never mind, I'm just going to do it myself. This whole second generation of AutoML that I'm going to describe isn't just developer-oriented with very robust APIs, which creates some exciting opportunities that I'll talk about. It's also very inexpensive. So it's not just Augur, but just Google, Amazon, of course, announced their AutoML product this week, so this is, or last week, so this is very timely. At reInvent, they announced their product, and Microsoft, and ours are all very approachable, pay-as-you-go cloud services. So, and if you want to talk more about AutoML and what it can do, please come to the booth afterwards. I'm going to try to stay away from talking about why you might want to. I am going to stay away from talking about why you would want to use Augur's AutoML versus others. So you can talk about it with me directly in the booth or later. So most commercial AutoML products use something called grid search. We talked about it, it's an infinite problem, choosing the algorithm hyperparameters. Grid search means try stuff, right? You have a grid of all the algorithms and then all the hyperparameter settings, and of course, it is an infinite problem, and they sort of hop around. Some of them say we do random search. Is random search different than grid search? No, it's not. It just means hopping around randomly in the grid. That's all it means. The best AutoML, and AutoML's been around in academia, is actually what's the preeminent university for AutoML? It's actually here in Germany. It's University of Freiburg, and they really pioneered it. You Germans pioneered AutoML. And ironically enough, University of Freiburg sponsors this contest called ChildLearn, and all these academics are entering this stuff, and there's no grid search. Everybody's doing some kind of Bayesian optimization search to intelligently traverse this. It is ironic that some of the earlier, without naming names, some of the earlier AutoML products were grid search oriented. And I'm bringing up this history because of those of you that sort of tried it and said, nah, I'll just do it myself. Yes, if you're using a product that does grid search, you probably can outperform it. Some of the more recent efforts, certainly Augur, but also others like Microsoft, are using Bayesian optimization, so they're intelligently traversing this infinite space. But the good news, if you're sort of maybe skeptical about this, is that research has been out there in academia using Bayesian optimization to do this for over 10 years. But one thing that absolutely has changed, another thing that absolutely has changed is first generation AutoML, and I'm talking about people like DataRobot, H2O, was, and this is not a bad thing, it's good that people were taking this great research and creating commercial products, was not focused on developers. If you actually saw any of the marketing, there's a business analyst or a citizen data scientist, you upload your spreadsheet, it tries all the algorithms, it gives you a leaderboard, and you pick the winner and you deploy. And that's not bad, but if you can actually automate all of these steps, it actually opens up some exciting opportunities to actually start potentially replacing business logic in apps. And so that's as much as I wanted to say on sort of what is first generation AutoML. So let's talk about what this second generation of AutoML is. It's a focus on automating AutoML. And we'll talk in a minute about what those different phases are. Now, I would actually put Google and Azure very much into this product. On Google, there's no leaderboard. I would encourage you to try the product. I would encourage you to try Augur. They're both free to try. Google's free to try, Augur's free to try. Augur is actually free for small to mid-sized models. They have very robust APIs. Now I'm going to talk about maybe some of the gotchas with the APIs, but they have very robust APIs that automate the entire process. And so if you sort of step back and say, geez, first generation AutoML let me automate, I don't have to hand select and tune the algorithms, but if you can automate that whole life cycle of getting the data to it, tuning the training, evaluating the algorithms, with your own evaluating the algorithms and hyperparameters with your own code, deploying the algorithm, predicting, and reviewing, you can actually automate these problems from beginning to end. You don't have to sort of like have this idea that the citizen data scientist or the business analyst uploads spreadsheets and looks at the results. You can actually build little predictive models as you go. And this is what I'm saying second generation automated machine learning about, and this is what I mean by AI is eating software. If you can build predictive models on the fly, you have the opportunity to start replacing business logic in code. So what do I really mean by that? What does it mean to replace business logic with code? So think about your typical enterprise app. You're almost always like sorting things. I'm going to give you an example of this. This medical app that lets people that are suffering from myeloma, which is a disease that medical science doesn't even know. They know the treatments, but they don't know what works best for what people. We actually sort, in this example, we sort the data in a certain way. Maybe people had business rules, but now we sort the treatments by how likely it is that they will recover. Other examples are, you have a CRM app and you're trying to tell the salespeople what to do next. Now, your typical CRM app will have some kind of sort that does, sorts it by the last customer they contacted, or sorts it by the size of the business opportunity. There's all these, what used to be called business rules. But the idea that you have to start hard coding business rules goes away. If you know you have an objective, like I want my sales guy to sell the most, you can predict, okay, who should he call next to get the best results? This applies to inventory management. We have another case study that I'm not going to go into here, but I have in the booth of a medical inventory supply company, and everything is presented in the likelihood that this inventory is going to get a stock out. Now, conventionally, you would write business rules that said, okay, these are what I want people to look at first in ordering. But if you have a predictive model, you can still have a human in the loop, but present the things in order that, present the drugs that they might want to order in order of the likelihood that they would run out. This can often get rid of long switch cases and if-then-else blocks. What it can also do, again, if you can automate the training and evaluation and deployment and prediction and review completely, then you can start predictive models with barely enough data. What I see a lot, and I would assume it's something that you've seen if you're a practicing data scientist, is you say, I want to build a predictive model to do something. And you either have no labeled data or very little. If you can automate all the steps, you can start with little labeled data, build a predictive model, get more labeled data as time goes on, and then completely retrain it. And if you always had to have a human eyeball in the loop, like looking at the results, that's going to be harder to do. Whereas if you can automate all the steps, then you can just completely, create a situation where you're training every night when you have barely enough data. And now some of you might say hey, wait a minute, I do that with conventional machine learning. I have my random forest algorithm, and as I get more data, I retrain it every night. But the reason why AutoML is so important to this scenario is as your data expands, you may need a different algorithm. In fact, it's very likely that some other algorithm is going to be better as your data size increases. What I would encourage you to do is think about using these AutoML tools and automating it and doing these things like choosing the sort, getting rid of if-then-else menus, getting rid of hierarchical menus. Don't make the user decide what they should do, you decide. You decide where you should take them based on a predictive model. This is absolutely next generation. For some of you, you might say hey, I just want to build my predictive model. But if you are a practicing data scientist and you're getting good results, think about embedding the insights further and further into code, not just using them to tell a person what to do, but actually to tell the software what to do. So my belief is this is a trend that it's way bigger than Augur, it's way bigger than all the AutoML that's there. What I believe is that you're going to see the results of all of this automated model creation and the ability to embed it in apps. You're going to start seeing apps get replaced from the inside out. So what are these fundamental phases? What are we really automating? If you look at all the automated machine learning tools, they all have these phases, all of them. Many of them use the same names, but even if they don't use exactly the same names, they have. So there's an import phase. It's getting your data to the machine learning optimized store so that it can do training. And you can say, well, wait a minute, isn't it just training from the CSV? All of the second generation AutoML tools, that's Augur, it's Microsoft, it's Google, it's AWS, they don't train right from the CSV. You get your CSV to some store that has identification of all the features, what's the target, what kind of metadata about the features themselves. You know, is it a categorical feature? Is it a binary categorical feature that was one hot encoded? Is it a numeric feature? So even though if you've used first generation AutoML, what you did is you're a user and you just uploaded the CSV and started looking, you could say, well, what's this import thing? All of the second generation sort of developer-oriented AutoML says you need to get your data to the AutoML service, and it trains off of it in some machine learning optimized store. So examples of this are of a machine learning optimized, something like Hive. But it turns out all of these AutoML have their own sort of proprietary machine learning optimized store. So this phase is common to all AutoML. Then there's a train phase where you try many algorithms and hyperparameters. Then there's an evaluate phase where you view models and choose one. Now that is analogous to what you would have done in, say, Data Robot or any of the first generation AutoML where you look at a leaderboard, right? You're looking at a leaderboard, it shows you all the algorithms, you pick one. Now, what's interesting is that doesn't mean that evaluate always has a leaderboard. For example, with Google, they don't tell you what the algorithms are. It's a black box. They just say, this is what's winning so far. But they absolutely do give you metrics on it so that you can decide, is this a good enough model? You know, what is my recall? What's my precision? What are the scores on the various scoring metrics? So there's very much an evaluate step that applies to all automated machine learning. Then there's a phase where you deploy, and that deployment is to the cloud or embedded. You should definitely look at whichever one you want to do and say, do I have to use a deployment where I have a runtime to do inferencing that's sitting in the cloud, or do I have the ability to download that model and run it at the edge or wherever I choose to do it? But either way, there is a distinct step where you've picked one of these models, right? You've evaluated as the best thing. By the way, when you evaluate, I say evaluate, some people say, I've heard like, evaluate, you just pick the thing that's the best score and go with that. Is that always true? If you had a leaderboard with a list of algorithms, would you always pick the most accurate one?
No, but it depends on the board, for example. How complex is the model or how fast it is.
Yes, okay, that's a good example. So an example is, no, you might not. You might say this is going to be too slow at runtime. You have a scenario where some models just take too long to predict something, and you say, the trade-off, what's another example of a factor? So one example is, you're going to look at that leaderboard and say, you know, I know about this model that this just takes too long to predict, so I'm going to choose the second best one because I know it's way faster. What is another classic example of something where you might not pick the winning model? Suppose, yes?
Maybe it's a bad model because it overfit or it underfit, so you have to look at those things also.
Yeah, okay, well I guess my opinion on that is that if you are doing good cross-fold validation, that you shouldn't hit that. You also want to make sure that whatever you use has cross-fold validation. Believe it or not, some of them only have train and test set where you're very vulnerable to that. So you definitely want to use some kind of cross-fold validation. I think you're less vulnerable to that. Let's suppose your winning model is a 4-layer neural network, and it's 0.95 R squared, and the second best model is 0.94 R squared, and it's random forest. Which one would you pick?
Explainability.
Yes! Okay. That's my plan. And no, actually, we've never talked about that before. So yes, there's a trade-off between typically with a practicing data scientist, whether you have AutoML or not, you're probably trading off between these three things, right? Accuracy is usually the most important thing, but also explainability, depending on your problem domain, especially in certain regulated industries, and also runtime performance. So those are the sort of big three things. Now what's exciting about an API for AutoML is you don't have to have the data scientist looking in that. That was the first generation classic thing. The data scientist looks at it and like sort of trades off between accuracy and explainability and makes a judgment about what they want to use. That's the reason to have a leaderboard. If you have APIs that will tell you these, you could actually have your software pick. You could say, I'm going to weight these different factors. And you can write code that trades it off, because it can be very sophisticated. It can be things like, I'll pick the most accurate thing and sacrifice something else if it's way more accurate, right? And so APIs for this stuff help you do that. So then, once it's deployed, then you can start inferencing with new data. After you do this for a while, this is the one critical thing that I don't think you've heard about before, which is that you owe it to yourself, and this applies to both automated machine learning models and just you hand-building models. What I've seen is I think not enough people spend time thinking about reviewing and monitoring to make sure the model continues to work. All models degrade. That's a controversial statement. I'm saying any predictive model that you build has a limited half-life. It's sort of like as soon as you're born, you're dying. As soon as you built that model, the model is dying. To greater and lesser degrees, depending on the problem domain. But all predictive models degrade over time. And I think most really good data scientists that I've talked to get that. But then when I say, how are you making sure that it doesn't keep degrading? I sort of get this I usually get a sheepish look. Well, I go rerun a training, with the actual data. That's not a good way. You don't want to continuously retrain. In most problem domains, you can't continuously retrain. You owe it to your customer and your business to make sure this model continues to work. So I'm saying this is a fundamental part of these phases. Now, some of you might say, what's this kooky thing? This really has nothing to do with the Augur product. This is my opinion of what the fundamental phases are. But did anybody see it was this really weird thing where they got a whole bunch of press about this Uber's Michelangelo project? Has anybody seen the write-ups of that? So that came out, a whole bunch of press last fall. It's very weird because there's no product. You can't buy Uber Michelangelo. And they have no plans to sell it. But they had all of this press about this thing. And they had exactly these phases with the same names. Google it now. Exactly the same names and exactly the same phases. We called it the PREDI pipeline. It's a corny acronym because it's hard to remember, ITEDPR. It's not because I'm French or anything like that. And so they didn't call it PREDI pipeline, but they did have the same names. And it turns out it's supposed to be in stealth mode. I'm not supposed to know about it, but some engineers from Uber went off and there's a stealth-funded company called Tecton, and so you'll see this, before you say, who cares about your silly little pipeline phase definition? The stuff that was in the Uber Michelangelo announcement, there's going to be another company that does that. Who knows? But my understanding is they're not doing the actual AutoML. It's more about just trying to provide the pipeline. But we've got the pipeline now. By the way, this pipeline is, if you say, well, wait a minute, is this pipeline a way to lock you into Augur? I'm going to show you later, I'm going to show a case study, and then I'm going to show you later this open source project that's called A2ML. It's free, it's open source, we don't control it. You can take it, fork it, never talk to us, and it does support Augur, Google, and Azure. And we will add, AWS, Amazon just came out with their AutoML, we'll add support for that. H2O has actually said that this is a really good idea. Like this whole idea of like a standardized pipeline and an API that's common to all things. If you're building software that uses AutoML, I would encourage you to use either that abstraction, that open source API, or at least think about your problem this way. So I want to talk to you about a case study of, this is a nonprofit that wanted to predict, it's a nonprofit trying to solve myeloma for patients. Myeloma is what's considered an incurable disease because medical science doesn't know what treatment to give you if you have myeloma. Doesn't know. It does not mean that everybody that has myeloma, this nonprofit is actually run by a myeloma survivor. Plenty of people survive and nobody knows why. So this is a great example of machine learning, because with machine learning, all these patients come up, suspend their HIPAA rights. That's some laws in the US about like what you can do with people's data, and they say, hey, here's all my data. This is everything you know about me, my genetics, my diet, where I live. And so we used AutoML. We started with 3,500 treatments from patients where they gave us all their data. That sounds really small if you're a practicing data scientist. Any ideas what the average myeloma research study, though, how many patients they're working with? Yes, dead on. It's actually below 100. And those are some of the bigger studies. So 3,500 is like infinitely large. But this is where AutoML is great, because you can start with 3,500 and get results. The other thing I'm going to say to you about why AutoML is so powerful here is that this data, because it was patient-directed, some of the patients gave all the information, some didn't. So it's very sort of spotty data. We had 400 patients, 400 treatments that were completely filled out, and we had 3,100 where there were lots of gaps in the data. So what we did is we cleaned the data based on various heuristics. So they tell you wrong stuff all the time, so we had to clean up the data. We iteratively imputed missing values. We did this all through code. And we were doing this, again, every night, so the whole pipeline was automated. We got additional things about the patient based on their zip code, like the population density and median income. That turned out to be very helpful to the model. We took information about treatment duration and past treatment info. We tried to predict it with this 5-class classification. This is very common in serious diseases. Like, I took this treatment, I got much better, a little better, same, a little worse, much worse. Didn't really get good results. We turned it into so we also tried it as a binary class problem and as a regression problem. And if you say, well, geez, how good can it be if you had to try all these different things? The fact is, I mean, it's considered an incurable disease because nobody, like, medical science doesn't know what treatments work. If you have myeloma or know somebody, hope that doesn't apply to you, it's very difficult to know what to do. So we started out with a naive approach using the raw data. We had 40% accuracy on the multi-class classification, 26% R-squared, which is of course horrible. You can't really do anything with that whatsoever. We added these handcrafted features like imputing stuff from zip code, got it up to 55% for multi-class and 60% for binary class. We did these cleaning heuristics and imputing data, got it to 68%. And then tuning the prediction threshold, we sort of like settled on, okay, this needs to be a binary class problem, like is this treatment going to make you better or not? And then we tuned the prediction threshold, like the threshold for which you say, I'm going to classify this thing as improving you, and that got it to 71% accuracy. And if any of you do anything in medical, the fact that we can actually say with 71% accuracy, is this treatment going to help you or not, is sort of, it's like unprecedented. Like in this field, like nobody knows what works, so everybody's shooting in the dark. Now, what the heck does this have to do with automating AutoML? So what this has to do is, this let us switch between different models very easily with AutoML. We were able to, within minutes, determine is the thing that was many features but only 400 observations better. We got 66%. This is before we tuned the threshold. Do we do less features though, with more observations and everything, a lot of the features are imputed? And it turned out, this is something, it's so at the margins that your judgment as a data scientist is not gonna work. I'm a data scientist, I've been doing this for a long time, and I had no idea which worked. But I can tell you that most practitioners would probably just pick one and go with it, because it takes a fair amount of time. If you have AutoML, you get results within minutes. And you can see it was very close, but we ended up picking the less features, more observations, using imputing, and we got slightly better results. And then we tuned the threshold, we got it to basically 68%. We tuned the thresholds, we got it to 71%. And you can see these are the feature, this is the feature importance that we have with it. What's nice about this model is it's not too weighted toward one thing. You can see it's fairly smooth between these various markers, medical markers for it. So in terms of what does the ITED, PR, or PRAD pipeline have to do with it? What we're able to do is take the data, evaluate the models, pick the model that's best. In this case, this is interesting because a lot of people say, oh, it's medical, it better be explainable. There's always some level of trade-off between explainability. It may be very, very small, but there's always a trade-off between explainability and accuracy. It's very, very rare, to the point where I almost never see it, that the more explainable algorithm beats the accuracy of the less explainable. When you're talking about people's lives, I believe you have an ethical duty. I happen to be on the board of this nonprofit, and I said we have an ethical duty to give them the best recommendation possible. So, so we pick the best model, we deploy the model programmatically as we get new data. We predict from the new data. By the way, those examples was like when we first did it. Like we have much more data now, so it's even more accurate. And then we start predicting. Patients come in, they say, this is what you know about me. And then all we do is show them the treatments in order. So think about this. It would probably be hard to say, do this, right? There'd be all kinds of liability things. But if you're going to show them what treatments are available, you want a way to do it in an automated way. I'm sorry. If you want to show, if you're going to show them the treatments available, you have to sort it in some way. Why not show the best ones first? And that removes the issue of like, oh, I'm liable because I told you to do this one thing. You show everything, but you sort it. So it's a good example of the value of automating the whole process and replacing business logic in the app. This is a web app that anybody can use, and it will tell them the treatments that are available in the order that it's likely to help them. I'm not going to go into this example. If you're interested in options trading, we worked with a large financial company to do this, what's considered an extremely difficult problem because 70% of options trading is done algorithmically. So when you options trade, you're always going against a machine. So if you can do a predictive model and get to, we actually got to a precision of 0.75, meaning 75% of the time we were right, that's sort of mind-blowing. Because again, there's a machine learning model on the other side of this. So you should never really get more than 50%. So my tips on applying AutoML to your business are always use AutoML for predictive models. Please come argue with me later if you think you should be hand-tuning this stuff. Even if you don't automate all the phases, think about all the phases, especially the review phase. What I've seen is most people don't really think about how am I going to ensure that my model continues to work. Ensure that you plan how all phases are embedded and controlled by the app. How do you deploy things? And then use this automating AutoML paradigm, this PRAD pipeline. It really isn't tied to my product, but think about, look at every product and say, how do I do each of these steps? By the way, how much time do I have? I couldn't quite read that sign. Somebody was holding up what I thought was a time limit sign.
10 minutes.
10 minutes, okay, perfect. I get to talk about A2ML. Okay, so here's this open source project called A2ML. Again, it's out there open source. It's not tied, yes, Augur supports it. It supports Augur, it supports Google, it supports Azure. We will add support for AWS. And what this lets you do is do all these phases: import, train, evaluate, deploy, predict, and view. So I'll actually just show briefly. Here is A2ML. Once you get clone, we give you both a CLI and we give a command line interface and a Python class. Some of you might say, shouldn't you give me, I don't know, a Ruby gem and other stuff? We'd love to see people do other bindings, but what we give you is a command line interface and a Python class. And you can just run A2ML, it shows you the commands. You say A2ML off and it logs in, and then you can see you have the import, train, evaluate, deploy, predict, and review for that. What this does is says, given these things, use declarative approach, YAML files. So say, what's the name of your project? Who are the providers? By the way, I could say the providers are Augur, Google, Microsoft. What's the source of the data? I can say what attributes given that source to remove as features. In this case, this is the classic Kaggle Moneyball contest that's trying to predict runs scored by team. And then you pick a target, and then you pick whether it's a regression model, a classification model, or a time series. You pick the number of cross-validation folds, the maximum total time to train, the maximum number of trials, and the maximum time per trial, right? You're trying all these algorithms. So you can set these parameters and they will work across all providers. We translate to basically gobs and gobs of code in Google and Microsoft's AutoML. So we're giving you a declarative interface not tied to any specific product. And as a matter of fact, if you said, well, isn't this just a proxy for locking you into Augur's API? Our underlying API doesn't look like this. We actually chose the names from Azure for like cross-validation folds, maximum total time. Those are actually, has anybody used either Google or Microsoft Azure's AutoML? Okay, nobody has. Those names are actually right from Azure. Now, it's not in a config YAML, it's from like code, but it's those names for the parameters because they were good names. And it gets you out thinking that it's tied to us. So what I'm going to do now in their time remaining is sort of look at, just to generalize, what do these phases mean in terms of code? So I apologize if you're not a developer, but to do each of these phases. So with Google, this is what you would do to get data from where it is into the machine learning optimized store. Now, in full disclosure, this does not include the getting from like a local CSV. A2ML gives you that. A2ML will take a local CSV or a CSV from a URL and then put it in Google's Google Cloud Storage because that's the only place they'll read from. So it puts it in Google Cloud Storage, then it moves it to a Google data set, and that is a proprietary store only for machine learning training. So this is the code to do it. And then I was mentioning the fact that this won't copy from a local CSV. So if you have a local CSV, that's the code. We actually use this command line thing called gsutil to copy from a local CSV if that's what you have. That's what A2ML does in its code. Again, it's all open source, so you can see what it does. In fact, even if you don't want to use A2ML, you can look at the code if you want to use it natively, because it's going to save you a lot of time traipsing through their documentation of like, how do I really do this? With A2ML, to do an import, you just make sure in your config YAML, you give it the source, and then you call A2ML import from the command line. And of course, we do have a Python library equivalent of that. If there's any students or interns here, we would definitely sponsor somebody like doing other language bindings for A2ML or maybe supporting other AutoML providers. So here's what you have to do with Google to do a training run. And by the way, some people have told me like, oh, this is just an excuse to harsh on Google. It's not, okay? I'm trying to sort of show that these different phases are the same across all these different AutoML. They all have an equivalent phase. Yeah, it's a fair amount of code and it's sort of awkward. The fact is, at least you can do it. With some first generation AutoML providers that are, you probably know who I'm talking about, like they just came out with an API and you can't do all these phases. You can only do some. No, but with Google, you can execute that code, and you can see what I'm doing is I'm identifying the target, I'm identifying the target column, I'm identifying which things are features, I'm giving it a train budget in milli-node hours, which is a very strange way of setting the time budget, but that's what they do, it's milli-node hours. Then I give it an optimization objective, which is minimize MAE. So that's the train phase. For Google to minimize the training run. And then you'll call, to execute the training run, you'll call create model. In this case, I'm doing it synchronously. That's not, I'm doing it for simplicity of code, that's not a practical thing. It is usually gonna take a long time. So you would do it asynchronously, you get a handle and tell it where to call back and tell you that it's done. I just was trying to show the simplest version of this is that you can actually have your app wait synchronously with this code, where you'll wait for, say, create model, then it trains, and you say create model response result, and then you'll get a result. So with training with A2ML, it's set those various parameters like we just showed in the config YAML, and then you'll either call from the command line A2ML train. Again, this would work against Google or Microsoft or Augur. You'll call A2ML train. And then evaluate. It's interesting, Google has the evaluate step, and they even call it evaluate, but remember, you're not going to get a leaderboard. So you'll call this code, it's actually fairly tight code, and then you'll get back for this project, this is how long it took, and remember, we picked MAE to guide the search, right? You're going to evaluate every algorithm. And so you say, I want to optimize for MAE, but it gives you the other metrics. Now, Google doesn't have a lot of metrics. I would actually say that's one of the other Achilles heels. They only have a handful, but you can see that they give you not just MAE, which is what you use to guide the search, but the root mean squared error, the mean absolute percentage error, and the R squared. So that's what you do with Google, and this is not that bad, so hopefully it doesn't seem like I'm harshing on Google now. But you can see with A2ML, which again you can drive Google or Augur or Azure, you call A2ML train with those parameters. Oh, sorry, I went backwards by accident. There's an evaluate with A2ML, and you can see what it's doing is it's giving you different model IDs, and then giving you the explain variance. It happens to be what we used to guide this particular search, and then it tells you the algorithm. And so you could look at that and say, I prefer this algorithm because I know what's faster, or I know what's more explainable. You know, you could, if you included a deep learning model, maybe you wouldn't choose it as the winner unless it was like way more accurate. And then there's a deploy phase. With Google, you'll call client deploy model, which is actually fairly tight code. With A2ML, you would look at that leaderboard, copy that hex string, and then say A2ML deploy and whatever that hex string was. Right? We just need to have some kind of common model. In this case, it deployed it to the cloud. There's a slightly separate syntax for deploying locally, where we give you a local Docker container if we can. That we can only do that for Augur and Azure because Google does not support local deployment for predictions. And then, so once you've deployed it, then you're going to want to start doing predictions. This is the command line to do predictions against a locally deployed model. You can see we say predict, we give it that model hex ID. We then give it a spreadsheet full of like a batch of predictions. With any system that you're probably going to want to do something like that because it takes a fair amount of time. You know, like if you have a lot of things you want to predict, you don't want to do them one by one. So you could do them one by one and just give it spreadsheets of these CSV files with one prediction at a time. let's see, it looks like did I show the Google Predict? Okay, I missed the Google Predict. I had cut that slide. I'll put it back in there. The slides will be shared and the code for that will be in there. So the final thing I want to say, maybe I'll sort of wrap up with this, is you know, as I mentioned, if you deploy a predictive model, you need to ensure that it continues to be accurate. This is what we spend a lot of time on at Augur. It is what, you know, apparently what you know, Uber Michelangelo spent a lot of time on, and what some other startups that are starting up now are doing. It's not something that is in any of the other AutoML vendors today, but it's something that I would encourage you to think about. How am I going to model predictive accuracy? So the final thing I wanted to mention is futures for A2ML. We want to finish Azure AutoML implementation. It's not quite complete. You'll see it if any of you have been on GitHub. We're not done the Azure stuff. We'd love to have somebody help finish that up. More complete documentation, it needs it. The code's there, but it needs better documentation. It's something I'll be working on. And then we're going to be doing a lot of sample apps with blog posts. In fact, this is what my whole company is working on, is really just, you know, fleshing this out. Our stuff's accurate enough, so we're spending a lot of effort on A2ML. And then we want a more robust definition of review. And so we're adding more and more sort of monitoring of not just like what's the overall accuracy, but what's the accuracy over time, aggregating the data over time. Of course, we have to expose an endpoint for you to send actuals to. And then we will be adding support for other AutoML providers. It's probably, you could call it SageMaker or Amazon. We will certainly do that. I'd love to see either H2O or Teapot, you know, use this common pipeline to do it. If you are another machine learning vendor and you want support for your platform, it'd be great to have your check-ins on it. And we're open to making other people committers on this. So if you are a developer, again, we want this to not be tied to our product in the way, and probably unconsciously, there's a lot of stuff that's tied to Augur. If you're a developer and you're this intersection of developer and data scientist, and you're building predictive models and trying to build them in apps, hopefully A2ML has piqued your interest. So we would love to get your feedback. You can just like send us email. But if you're interested, we are looking for people to be on an advisory board to sort of, you know, tell us where we should take this. Potentially be co-contributors, but we are going to formalize this advisory board thing. Basically, we're just looking for 2 hours per month commitment of essentially, you know, using the framework and telling us what else it needs. The whole thing's free, not tied to our stuff. If you're writing with other AutoML, hopefully it could be really useful to you. So with that, I'll wrap up. And do we have time for a couple questions? Do I have like some monitor here that's controlling this? This is, Europeans do everything better. In the US, there'd be somebody like pulling me off the stage now. So with that, any questions about the pipeline or A2ML?
Yeah, it's Steve. I missed the top spot of your pyramid. I'm not sure. The question is like, so you're targeting the data scientists, which are probably the majority in this room here. But is there a goal for still this citizen beta, so the domain expert who's going to be using
Yeah,
it?
no,
is there a top part?
Don't get me wrong, like first gen AutoML, I'm saying even first gen AutoML, you've got something that is training against all these algorithms. This is huge value, you know, so kudos to Data Robot and H2O for sort of plowing the ground and taking all this cool research done at University of Freiburg and elsewhere and giving you a product you can use. What I'm saying is, if you can, but those products were absolutely targeted at citizen data scientists, and you couldn't automate all the steps, right? You came to those products with a spreadsheet that, you know, some IT person gave to you, right? That came out of the database, and there was all this work to, you know, identify, like, have columns for all the features and have the target, and that's real work that I don't mean to minimize. My point is, what if you look at that process, instead of saying, well, I come with a spreadsheet and I get the model, and then I have the chosen model and I train it, and then it's somebody else's job to put it into a system. If you can use this pipeline, it just gives you more things that you can solve. You know, you can solve other problems. Like we couldn't have done what we did with the health tree app if we didn't have the ability to automate everything and, you know, get new data from them every night. That allowed us to create an app that inside the app, right, was automated AutoML. But this is not denigrating first generation AutoML. If you're not using it and you're not a developer, I would encourage you to use it regardless.
My point still is that I believe that at some point in time the domain expert is going to get tools for domain expert, which is not a data scientist, to be using and taking value out of data themselves.
Yes.
My question to you is, do you see that's going to happen or not?
Yeah, no, I think that's valuable. I mean, whether you say that's a future or not, I would put that into the first gen bucket where the consumer of it is, instead of an application, the consumer of it is a person with eyeballs that uses their judgment. And that's very often a useful thing to do because you can use your judgment and, you know, maybe use a tool that lets you give a few values to it and get results. So this doesn't mean second gen is better than first gen, it's just part of a progression. And if you said, what's sort of like, where does it end up heading? Was that like, is there a third gen? Is that what you were getting at? If there's
that's normally what a pyramid.
Yeah. So I actually had it, and I felt it was a bit of a red herring to some people. I believe after the second gen, where you can at least automate all the phases, that pipeline is not completely arbitrary. It really does map to what everything does. I think eventually, as it's more and more popular to use this inside apps, it'll be even simpler. And I call that sort of final phase, third gen, like I call it like Twilio for prediction, where you have a simple API that just says train, and it does the import, train, evaluate, deploy, and then run. And then run does the predict and review. I don't think, I think like even this second gen is just emerging. And I think that's the exciting thing that I think developers and data scientists should work on. I do think there'll be a version that's even simpler. Yes?
The way I understand you want to differentiate from AutoML is by being more transparent a little bit about the models that you're choosing, because you still have the leaderboard and show what AutoML is actually doing. Do you have plans also to make the models exportable so I can run them on edge devices?
Yeah, that was in that deploy phase. I said that actually many AutoML products have that ability to do. So Augur has that ability, and so does Augur has that ability, and so does Azure. Google does not. I'm saying in this general framework, I really wasn't. If you said how is Augur different, it has to do with like how we get more accurate models, but I didn't really want to talk about that now. This really was. I'm saying that these phases. It's not an artifact of Augur, it's something that really applies to all of these AutoML things that have an API. Yes?
So you were talking about getting the data into a data store, and my naive understanding is that these AutoMLs are not something that I can deploy on my own servers. So if I'm in a GDPR compliant environment, I can't really export my data up to the servers?
No, what it's saying is that even if you had something that you can run locally, that these products work with, they don't just run directly from a CSV. They run off of a data store. I mean, it may be an on-premises system, but it would run from something like Hive, which is a data store that's focused on identifying features and targets. So I'm saying that even if you run something on premises, we do sell Augur on premises. Google and Microsoft happen to not be on premises, but I'm sure there will be other second gen AutoML besides Augur and Google and Microsoft that does allow you to install it locally. I'm saying that when you do that, you won't have this thing where the train just runs right from a CSV. There will be an import step that puts it into a data store that's optimized for that iterative training.
Got it. So what, the short answer for me there is I can't use Google or Azure right now.
You can't. You could use Augur, but you can also use, you could also use H2O, the open source H2O. You can install locally, not the driverless AI, and DataRobot will sell you an on-premises thing. I am sort of saying that if you look at all these steps, some of the other vendors not Google, Microsoft, that have all these steps, have work to do on providing all these phases in there. Yes?
So where do you see this thing going, like the third generation? What is the major advancement going even further?
Well, I personally believe that once people accept this idea of completely automating this stuff, you know, automatedly picking winners, automatedly deploying, like once that pretty pipeline is completely automated, I do see it being, instead of like having to worry about 6 phases, it will be this thing where you just say, train it, right? And it does the ITED, and then there's just runtime predictions, and then everything happens automatically, including like you do the predictions and it's keeping track of it real time and saying, oh no, now it's not accurate enough, just retrain the whole thing. So, and that would be that next level in the pyramid. What I'm encouraging people to do is like, don't wait for that, right? Use this, whether it's with the A2ML API or just writing directly to Google or Microsoft. You can do a lot of exciting things explicitly using each of those 6 phases.
So maybe I can add a question. So this is mostly now supervised learning structure.
All supervised learning, yes.
What about unsupervised learning? Would there be a way also to utilize this, or do you see no, it's not?
The products that I'm talking about are very focused on supervised learning. Isn't necessarily always with completely structured data, but I believe this pipeline applies to the supervised learning problem, which I think is the vast majority of sort of enterprise machine learning that I'm seeing. Okay, thanks very much.